Micro LED is generally considered the end game of panel technology. It's supposed to have the longevity of an LED LCD panel and the perfect blacks, the perfect colors of an OLED without the burn-in risk, of course. So they're supposed to be microscopic, self-emitting, infinite contrast ratio, colors that pop, and because they're inorganic, they are supposed to be reliable as well. So up until now, Samsung has been at the forefront of this technology ever since they introduced the wall back in 2018, if I'm not wrong, at CES. And they've been pushing this technology ever since. Over the years, they've made a lot of progress in this. But still, there is very less competition to Samsung, almost non-existent. There are only two more manufacturers that are manufacturing micro LEDs at scale, but not as good as Samsung is. The difference is that Samsung is using active matrix and the others are using passive matrix. But up until now, LG has just announced their Magnit series of micro LEDs, which they've just launched. And with that, obviously comes a very hefty price tag. These TVs are definitely nowhere near cheap. They'll probably cost you more than a luxury car, around about at $300,000. Samsung similarly comes up at $150,000 to $200,000. And a company called AWOL does offer it comparatively lower at around $25,000 to $30,000. Now, the main thing in micro LED is the pixel pitch. So pixel pitch is basically the distance between each pixel. Now, this pixel pitch or the distance between each pixel has to reduce if you want to make screen sizes like 65, 75, or even 80 inch, which are more popular in consumers. 100 plus inches are still extremely rare in consumer scenarios. So in order to achieve this, they have to reduce the pixel pitch to below 0.5 mm. And that still hasn't been achieved. Samsung is at 0.51 mm as of now. But for smaller sizes, they have to reduce it probably to 0.3 or 0.4 mm. Only then will the pixels be indistinguishable at normal viewing distances at normal screen sizes like 55, 65, 75 inches. So LG with its new series, the Magnit series, they've come out with a 136 inch TV, which has a pixel pitch of 0.76 mm. Now, this is comparatively higher than what Samsung has to offer, and it also commands a premium over Samsung. Now, the technology over here, they use active matrix as well as what Samsung does. And LG says that this makes their picture quality better. Now, obviously, I don't have any way of verifying this, but that's what they say. Now, brands like AWOL, they use passive matrix, and brands like Samsung or LG, they use active matrix. What's the difference? Why do they use active and passive? So in active matrix, you basically have pixel level control, whether it's brightness or the contrast or how much color goes. You have individual pixel level control. In passive matrix, you don't. So you get reduced color accuracy, reduced contrast ratio, and that OLED-like picture quality just isn't there. So active matrix, with what Samsung and LG are producing, that's the way forward in order to achieve that perfect display. But obviously, all of these things do come at a cost. And the cost is, as of today, is extremely high. Now, the major differentiator as of now between LG and Samsung is first the pixel pitch, second is brightness. Now, when compared to Samsung, LG has a lower maximum peak brightness, which is capped at 500 nits. This is to ensure that you have perfect details, perfect blacks, and the brightness is not overpowering. Samsung, on the other hand, limits its brightness to around 1000 nits. Now, when you see brands like AWOL, these are typically generic chip-on-board modules from major Chinese OEMs like Epson or Unilumin. Usually feature large pixel pitches around 0.9 mm to 1.2 mm, relying on older passive matrix driving. Now, these function as dumb monitors and they lack all the video processing that's required. So for the legendary rivalry between LG and Samsung, this is another topic that they've been competing for the past, I think, 15 years. Whether it's AMOLED or LG's OLED or qd-OLED or IPS, VA, LG and Samsung have been at it since as long as I can remember when compared to any technology that they're developing, especially in terms of display. So safe to say the race is on. Let's see who reaches a pixel pitch below 0.5 mm and who can reduce the price so that it's available to everyday consumers. and replace hopefully OLED one day.